You know, when we think of July 4th, we usually picture fireworks and barbecues. But in the world of mathematics, it is an absolute goldmine of a date. Welcome to this explainer. Today, we're going to follow the structure outlined in the source document titled ENGV to trace an incredible, almost unbelievable mathematical lineage. Because on this exact day, across different centuries and totally different continents, three brilliant minds literally laid the invisible groundwork for our modern, hyper-connected world. I know, it sounds like a massive exaggeration, right? But the actual fundamental architecture of the reality we live in today traces right back to the sheer coincidence of this one day on the calendar. Let's dive in and see exactly how this whole shebang unfolds.
I mean, just think about the device sitting in your pocket right now. It can map a route across a gridlocked city, handle a million background tasks without even breaking a sweat, and snap a flawless high-res photo all at the exact same time without freezing up. For most of us, it kind of just feels like pure magic. But behind the screen, it's pure elegant logic. We're talking about a symphony of calculations firing off in mere milliseconds.
And the timeline of that underlying logic shares this wildly uncanny coincidence. Yep, the golden date of July 4th. We're looking at three distinct individuals, born or memorialized on this exact day, who are basically the silent architects of our digital lives. Now, obviously, they weren't out there building smartphones, but the abstract math they developed decades and, in some cases, centuries ago, those were the exact puzzle pieces we needed to make our modern tech function flawlessly today.
So how does your phone actually think fast enough to, say, load an app or fire off a text message without a hitch? Like, what is the hidden architecture making those lightning-fast decisions inside those microscopic chips? Well, before a device can show you a map or take a selfie, it fundamentally has to know how to process basic info. It desperately needs a language of absolute certainty, a way to filter our messy reality into strict binary choices.
And that foundation? It takes us all the way back to July 4th, 1906, in Scotland, with the birth of Daniel Rutherford. This guy was a phenomenal mathematician who eventually became the Gregory Professor of Applied Mathematics at St. Andrews. And look, long before anyone even dreamt of a microchip, Rutherford was just deeply immersed in the world of theoretical math. He was exploring these incredibly abstract concepts that honestly probably seemed totally disconnected from everyday life back then.
But here is his massive contribution. His exploration of Boolean matrices. Essentially, by taking the absolute core logic of true and false and organizing it mathematically into matrices, Rutherford created a robust framework for structured decision-making. And today, that exact mathematical language is what allows modern phone circuits to process information. We literally rely on his logic with every single interaction. His matrices act as the foundational grammar for all those digital commands firing across your device's motherboard right now.
It's just a fascinating reality to wrap your head around. Every tap, every swipe, every quick keystroke on your screen is secretly powered by this deeply hidden pattern of true and false math. It's beautifully organized logic just running endlessly in the background. Without Rutherford's framework, the complex, branching decisions that allow your operating system to function at all, they simply wouldn't exist in the efficient way they do today. It is binary decision-making completely perfected.
Okay, so Rutherford's logic is a huge piece of the puzzle, but it's really just the first layer of the stack, right? It gives our devices the ability to think, sure, but absolutely no way to navigate the physical world around us. So we're still on July 4th, but let's jump forward in time to the year 1923, where a totally new layer of our digital reality was just getting started. It's kind of crazy how much this single date on the calendar keeps delivering.
Now, if logic powers the internal decisions, geometry is what powers our movement. Think about it. Why does your GPS effortlessly render a flawless 3D route, no matter how chaotic and twisted the city streets get? Mapping continuous spaces without the whole system just completely breaking down requires a fundamentally different mathematical approach. It needs a way to translate the totally unpredictable curves of the real world into something a computer can reliably understand and project.
And that specific approach? That originated with Dan Mostow. He was an outstanding mathematician born in Boston on, yeah, you guessed it, July 4th, 1923. Mostow spent his entire career working on these incredibly complex geometric and topological problems. And while he definitely wasn't out there writing software for navigation satellites, his deep theoretical work gave us the exact mathematical constraints we needed to solve one of the absolute hardest problems in digital rendering and spatial awareness.
So Mostow's big breakthrough came in the form of what's called strong rigidity theorems. Basically, he uncovered this profound way to lock flexible topological shapes into unbreakable continuous geometric rules. And today, it's those exact unbreakable rules that let our software render stable, accurate 3D maps without the geometry just randomly collapsing or distorting on you. Whenever your mapping app smoothly rotates around a city block, it's directly relying on the rigidity that Mostow proved mathematically.
So next time you're stuck navigating some tricky, chaotic intersection or panning around a digital globe, keep this in mind. The digital maps guiding our everyday journeys are fundamentally built on those unbreakable rules of geometry. We literally navigate the physical world using Mostow's mathematical constraints. It's just a perfect, shining example of how purely theoretical math eventually trickles down to become this absolute essential utility in our daily lives.
All right, so we've got the logic down, and we have the geometry figured out. But what about the visual data, the stuff we capture every single day? Well, that brings us to our final story. Same date, 70 years later, and an idea that completely shapes our modern visual world. Because once our phones could think and navigate, the very next frontier was allowing them to see and to process what they were seeing with just blinding speed.
Think about the camera on your phone for a second. How on earth does it process a photo so incredibly fast? Like instantaneously translating a totally chaotic burst of light into a crystal clear digital image right there on your screen. What is actually happening in that tiny split second between the moment you tap the shutter and the moment a perfectly balanced, color-corrected image drops into your camera roll?
Well, the mechanics behind that split-second rendering trace right back to a brilliant pioneer in numerical math, Alston Householder, who passed away on July 4, 1993. Householder was an absolute giant in his field, and he dedicated a massive chunk of his life to figuring out how to handle gigantic calculations efficiently. And as it turns out, it was his sheer obsession with computational efficiency that really paved the way for modern digital imagery.
See, back in the 1950s, numerical linear algebra was, frankly, incredibly chaotic. Householder's true genius was bringing order to all that chaos by organizing these vast, unruly arrays of numbers into highly efficient matrices. Fast forward to today, and his specific mathematical transformations serve as the literal algorithms processing the digital images and graphics on our screens. His work is the reason that the millions of pixels captured by your camera sensor can be calculated and arranged practically instantly. I gotta say, it completely changes how you view your camera roll. Every single digital picture you take is, quite secretly, made of math. It's just a beautifully organized grid of numbers, calculated in milliseconds, made entirely possible by Householder's incredible work. What looks to you like a stunning sunset or a super sharp portrait is, at its absolute core, the result of Householder's highly efficient linear algebra transformations executing flawlessly right there in the background.
When you really step back and look at it, the scope of this historical coincidence is just amazing. You've got Daniel Rutherford building phone logic in 1906, Dan Mostow mapping our 3D world in 1923, and Alston Householder processing our visual data in 1993. Three highly distinct minds, spanning practically a century, inextricably connected by July 4th. Together, their completely separate theoretical work compounded over time to form the technological foundation that you and I interact with hundreds of times a day.
Every single one of these mathematicians was essentially asking the exact same question: what is the pattern hiding inside the chaos? And because they searched so relentlessly for those answers, we now carry literal supercomputers in our pockets that seamlessly process logic, space, and light. So, I want to leave you with this thought. What patterns are hiding inside the chaos around you right now? Keep wondering, keep exploring, and thank you so much for joining me on this Explain